Ever wondered how your browser communicates with a server? It's a fascinating process, really. At the heart of it all is client-server communication, a fundamental aspect of internet programming. It's all about exchanging data and services over a network. But how does this happen, you ask? Well, there are various methods and technologies that make this possible, each with its unique characteristics and best-suited scenarios. From the ubiquitous HTTP and HTTPS, which are the backbone of web browsing, to WebSockets that provide real-time, full-duplex communication, and even AJAX, a technique for asynchronous data exchange. We also have RESTful services, a popular choice for creating interactive APIs, SOAP for complex transactions, RPC for service requests across networks, and good old FTP for reliable file transfers. Intrigued yet? So what are these different methods of communication? Let's dive in. First up, we have HTTP and HTTPS, the backbone of the internet. HTTP, or Hypertext Transfer Protocol, and its secure counterpart HTTPS, standing for HTTP Secure, are the most common protocols for client-server communication on the internet. These protocols are like the highway of the digital world, primarily used in web browsing. When you type a URL into your browser, you're sending an HTTP request to a server. The server then responds with the requested data, be it a web page, an image, or a video. What makes HTTP and HTTPS unique? They're stateless and connectionless, meaning each request is independent and doesn't require knowledge of previous requests. This makes them versatile for transporting any type of data. They're the go-to method for web applications, RESTful APIs, and websites. HTTP and HTTPS are the most common, but there are other methods that offer different advantages. Imagine having a real-time conversation with a server. That's where WebSockets come in. WebSockets open an interactive communication session between the client's browser and a server. This technology stands out because it provides full-duplex communication channels over a single, long-lived connection. Essentially, this means that both the client and server can send data simultaneously without having to wait for the other to finish. This leads to low latency and provides an efficient way of handling real-time applications. So, where can you see WebSockets in action? Anywhere where real-time interaction is key. This includes live notifications, online gaming, and chat applications. These platforms need to process high volumes of data quickly and efficiently, and WebSockets are perfect for that. So, WebSockets offer a quick, interactive way to communicate. But what if only parts of a web page need to update? For more dynamic web experiences, there's AJAX. AJAX, which stands for Asynchronous JavaScript and XML, is not a technology, but a technique. It's like the secret sauce that makes your web pages more interactive and user-friendly. At the heart of AJAX is the XML HTTP PA request object, a browser built-in function that requests data from a web server asynchronously. It means that AJAX can fetch data from the server and update parts of a web page without the need to reload the entire page. This results in a smoother, more seamless user experience. Imagine you're typing in a search box, and results start appearing as you type. Or you're filling out a form and getting real-time validation feedback. That's AJAX at work, providing dynamic content updates. But AJAX isn't the only player in the game. For building more interactive APIs, we have something called RESTful services, but that's a tale for another scene. AJAX provides a seamless user experience, but for more interactive APIs, we have RESTful services. When it comes to interactive APIs over web services, REST rules. REST, which stands for Representational State Transfer, is an architectural style that explicitly uses HTTP methods and revolves around resource-based URLs. This makes it a popular choice for creating interactive APIs over web services. One of the key features of REST is its stateless nature. This means that each request from client to server must contain all the information needed to understand and process that request. This statelessness allows for greater scalability, as the server doesn't need to store any context between requests. REST also makes good use of standard HTTP methods such as GET, POST, PUT, DELETE, and more. This allows for a wide range of actions to be performed on resources, making REST a versatile choice for many applications. Common use cases for REST include web APIs, microservices architectures, and mobile application backends. As you can see, REST is great for scalable web APIs, but for complex transactions, we have SOAP. For complex enterprise-level transactions, there's SOAP, Short for Simple Object Access Protocol, SOAP is a protocol used for exchanging structured information in the implementation of web services in computer networks. It's a heavyweight, meaning it carries a lot of information in each message. SOAP's defining feature is its protocol independence. It can use almost any transport to send a request and receive a response. Most commonly, it uses XML for message negotiation and transmission, but it can also use SMTP or HTTP. What sets SOAP apart is its ability to support complex transactional operations, making it a popular choice for enterprise-level web services. Financial services and telecommunication services often rely on SOAP to handle their complex transactions. But SOAP is not the only player in the game. While it's well-suited to complex transactions, it can be a little heavy for lighter tasks. SOAP handles complex transactions well, but for function call semantics, we have RPC. When you want to make a procedure call over the network, RPC is your method. Remote Procedure Call, or RPC, is a powerful protocol that allows one program to request a service from another program located on a different computer, all without having to grapple with the intricate details of network communication. RPC operates as a function call, making it incredibly straightforward for programmers to use. This protocol shines in its ability to abstract the complexities of network communication, allowing developers to focus on the logic of the application itself. Essentially, RPC makes a network of computers behave like a single computer. This feature makes RPC an excellent choice for distributed systems, where tasks are divided among multiple computers. It's also commonly used in network services and cloud computing services, where RPC can provide efficient, seamless communication between different parts of a system. RPC is excellent for distributed systems, but for file transfers we have FTP. Last but not least, when it comes to transferring files, nothing beats FTP. FTP, or File Transfer Protocol, is a standard network protocol used for the transfer of files from one host to another over a TCP-based network, such as the Internet. It's not specifically for client-server application data exchange in the traditional sense, but it plays a crucial role in moving files around in a networked environment. FTP shines with its reliability. It ensures that files get from one place to another intact, making it a trusted choice for important file transfers. Moreover, FTP supports authentication, meaning only authorized users can access the files, adding an extra layer of security. FTP is commonly used for file sharing, website publishing, and data exchange in networks. Whether you're uploading a new web page to your server or downloading a software update, FTP is the go-to for reliable file transfers. So there you have it, 7 different methods for client-server communication. Let's quickly recap. HTTP and HTTPS are the workhorses of the Internet, providing the foundation for data exchange in web browsing. They're stateless, connectionless, and versatile, able to transport any type of data. Then we have WebSockets. These are the go-to for real-time applications, offering a full-duplex communication channel over a single, long-lived connection. If you're building a live notification system, an online game, or a chat application, WebSockets could be your best bet. Next up is AJAX, a technique that combines several technologies to enable asynchronous communication. It's a favorite for dynamic content updates, allowing parts of a web page to be refreshed without reloading the entire page. And let's not forget RESTful services, an architectural style that leverages HTTP methods to create interactive APIs over web services. Stateless and scalable, REST is often used for web APIs, microservices architectures, and mobile application backends. SOAP, on the other hand, is a heavyweight protocol for exchanging structured information in web services. Though it can be more complex, it's protocol-independent, standardized, and supports complex transactional operations, making it a popular choice for enterprise-level web services. The RPC protocol allows a program to request a service from another program on a different computer, hiding the details of the network communication. It's widely used in distributed systems, network services, and cloud computing. Finally, we have FTP, primarily used for transferring files between a client and a server. Though not traditionally used for application data exchange, it offers a reliable method for file sharing, website publishing, and data exchange in networks. Whew, that was a lot to take in, but remember, each method has its strengths and is suitable for different scenarios. Your choice depends on the needs of your application, whether it requires real-time communication, asynchronous updates, secure data exchange, or anything else. Remember, the best method depends on the needs of your application. Until next time, keep exploring and keep learning.